It's 3 o'clock. We'll go ahead and get started here. So hello and welcome to Advances and Emergent Needs in Paleo Geoscience Cyber Infrastructure, a webinar series organized by C4P. C4P, Collaboration in Cyber Infrastructure for Paleo Geosciences, is an EarthCube research coordination network supported by the National Science Foundation. I'm Doug Fills, and I will be the moderator today. Leslie Shee will be running the WebEx. In today's talk, we have two presentations, each 20 minutes with roughly 10 minutes for questions. We want to keep this to an hour, so I'll be fairly strict about enforcing time limits, and we'll give each speaker a 3-minute warning. If you have questions, please send them through the WebEx chat window, and Leslie will read them aloud after the presentation. You may send in a question at any time. All presentations and follow-up discussions will be publicly archived on the EarthCube website at C4P and at the C4P YouTube channel at youtube.com/Cyber4Paleo. Our first speaker today is Kerstin Lehnert of IEDA, Integrated Earth Data Applications at Columbia University, who will be speaking about the Geosamples website services and IGSNs. Our second set of speakers is led by Sky Bristol of the USGS. Their presentation is titled, Working to Get the USGS Paleontological Records Straight. We'll begin with Kerstin Lehnert. Welcome, and you may begin when ready.
Yeah, hi everybody. I hope you can hear me well. If not, please put it in the chat. So I'm excited to give you an overview of the International Geosample Number and the Geosample services. And this is addressing the issue of physical samples as part of an earth science cyber infrastructure. The paleobiosciences have samples at the foundation of their research. And therefore, the Research Coordination Network, C4P, has made samples and their integration into digital data infrastructure one of their foci. But there are many other domains in the earth sciences that care very much about samples and where observations are made on samples taken in the field or produced in the lab. And I've listed a number of the EarthCube end-user domain workshops that actually talked about samples on their agenda. During these workshops, very common challenges were revealed, and they pertain to the preservation, discovery, and access of samples. And just to give you one example from the petrology and geochemistry workshop was a statement, or is a statement from the executive summary of that workshop, that poor and uneven access and management of sample collections, the incomplete sample tracking and linking of samples to analyses in the literature and databases, and the discoverability of existing samples is a problem for this community. Now, digital data infrastructures actually can address many of these challenges with physical samples and offer new opportunities. For example, online sample catalogs, be they federated or central, can help the discovery and access of samples so they can be better shared and reused. It will help investigators to find out where samples are actually stored in archives or in labs so they can access them for verification of sample-based observations. And there is an opportunity to access sample metadata so that sample-based data can be better reused and properly interpreted. Digital data infrastructures also offer the opportunity to link data, samples, and publications, and for the first time actually to easily link data acquired on a single sample but stored in distributed data systems and in distributed publications. And shared cyber infrastructure can also help with the management of collections and samples, be they in larger institutions or in small personal collections. But building such an internet of samples has 3 basic requirements. The first one is that samples need to be uniquely identifiable. The second one is that there need to be digital metadata records, so to say virtual representations of these samples. And the third one is that the unique identifiers actually link to these virtual representations. And these are the two efforts that in part address these demands for building an internet of samples. One is the International Geosample Number, or IGSN. Information is available at IGSN.org about this effort. This is to make available globally unique and persistent identifiers for physical objects. And the system works through an international federation of allocating agents, an organization called the IGSN-EV. And Geosamples is an NSF-funded effort that is actually operated through the IEDA data facility that provides tools and services for users to catalog the sample metadata, to register their samples with IGSNs and obtain them through these services, to ensure the long-term archiving of sample metadata and access to these metadata, and yes, I mentioned already operating the IGSN registration service. So here are a couple of examples of the IGSN for different materials. The way the IGSN works is that it is guaranteed to be unique because there is a centralized control mechanism that is operated by the IGSN-EV, and the IGSNs, the individual identifiers, do resolve to the virtual sample representations that are managed and stored at these federated IGSN allocating agents. And the way the system works, a user basically gathers samples and collects the metadata about these samples, submits it to an allocating agent through the tools provided by this allocating agent. The allocating agent creates an IGSN, sends it to the centralized IGSN registry where it is verified and uniqueness confirmed back to the allocating agent, who then sends the IGSN back to the user, and the user can start using the IGSN on sample labels or in data tables and publications. The way the IGSN architecture is designed, it has the central registry, which currently is operated at the Geoforschungszentrum in Potsdam in Germany. As I mentioned, they operate the IGSN handle service, they validate the identifier registration, and they manage and ensure uniqueness of the namespaces handed to allocating agents. The allocating agents provide the tools, such as I mentioned already, for registration. They can establish specimen metadata profiles, they validate the metadata content, and in general handle the interaction with the specimen collectors and curators. And at the end are the IGSN users who have to register their samples. They can ask for namespaces, and they actually, sure enough, maintain the physical collection. So the IGSN users are basically the people who collect or manage the physical samples. As I mentioned, the IGSN organization is a non-profit organization registered in Germany at the moment. It has bylaws that are modeled after the DataCite consortium that manages DOIs for data sets. An important aspect to keep in mind is membership in the IGSN-EV is only required for organizations who want to set up an allocating agent. Membership is not required to use the IGSN. Just briefly going over the syntax of the IGSN, it is a URI type identifier, alphanumeric, that consists of a namespace and a name-specific string, such as shown down here as an example. This is an ocean drilling program sample. The namespace ODP, here is the string of random characters that makes this, this IGSN unique. The characteristics of the IGSN are that they're mostly unintelligent, not having any meaning encoded in the name. They're broadly applicable to any type of physical objects in the earth sciences. And very important, the IGSN is not meant to replace any personal or institutional names. And I'm comparing this here to a name of a person, could be a name of a sample. And the person has an IGSN. And by the way, this is not my personal social security number. And in the same way as the social security number is used, the IGSN is used to identify an object uniquely. The syntax currently has been very strict at the System for Earth Sample Registration in enforcing 9 digits with a 3-digit namespace and 6-digit name-specific string. In the future, this will be handled on a more flexible base and more flexibility will be given to the allocating agents who can change the protocol slightly. We do this in order to accommodate the needs of large-scale users such as large core repositories or large scientific programs who want to hand out subspaces within their namespace. And we also realized that handing out 3-digit namespaces to users who will only register smaller numbers of samples was made us lose a lot of these numbers. So, for example, I'm showing here how the IGSN syntax can look in the future. The first row here shows the example from ODP again with ODP namespace and the name-specific string. The Bremen core repository had identifiers that had 7 digits after a namespace BCR, so they will keep their 7 digits here. The International Continental Drilling Program wants to have a short namespace so that they can assign name subspaces to individual projects with a shorter string, or here in the future, Geosamples may assign subspaces to individual users that would leave 4 digits for the name-specific string. But that should not be any concern. A 4-digit name-specific string still gives over 1.7 million alphanumeric IGSNs, so nobody should be running out. What objects can get IGSNs? Well, it can be locations such as drill holes or wells or soil pits and stratigraphic sections, as well as individual specimens or larger objects such as cores or dredges that may consist of multiple individual specimens. The IGSN has a core set of metadata that describes the sample, the sampling location, if that's applicable for some synthetic samples that might not be the case, sampling time, and so on. At the level of the IGSN registry, there will be only some administrative metadata, such as the link to the virtual representation of the sample and the name of the allocating agent. And at the level of the allocating agent, the metadata profiles can be extended to include any information that that particular community or institution deems relevant. And this is what the metadata profile in Geosamples and SESAR looks like at the moment. Again, identification, a description of the sample, including its classification, geospatial information, information about the collection, date, time, potentially larger expeditions and so on, and then information of where the sample can currently be obtained or who to contact. Important also is the relationship to other samples or subsamples taken from an object, so that we build entire sample genealogies or hierarchies linking to siblings and to children of a specific object. So the example here is an ODP core that has a parent, which is a whole. It has siblings, which are other cores from this whole, and many children, which are the sections within this core. So how is the IGSN applied? Well, both in sample management for the preservation and access of sample metadata, the tracking of samples, such as shown here already on an example where the QR code of the IGSN is used to track samples in the lab. The transfer of metadata to new owners, which makes the transfer of samples to new owners much easier. And then in data management, as I mentioned, the unambiguous citation of samples, being able to find and access data in distributed systems, and linking data samples and publications. And I'm very happy to show this slide because just yesterday the first publication came out on Science Direct that actually includes IGSNs that are tagged and linked directly to the metadata profiles in geosamples.org. We hope that in the future the inclusion of IGSNs in scientific articles will allow us to establish searches across the literature to find all articles that contain data for a specific sample. So in the last few minutes of the talk, I just wanted to show you some of the tools that geosamples.org provides for registration of samples and metadata management. This is a user account showing the different options for sample registration, viewing of already registered samples, and all the different capabilities like transferring ownership, searching collections, and so on. This is our metadata template creator. Users can define metadata that they would like to include in the registration in this tool, and they get an Excel spreadsheet, this template here, that it's sent to them, or it's downloadable with a quick guide for how to register, how to use the different metadata fields, and when this template is completed, it can be uploaded again to geosamples.org for registration of the samples. We have also built a mobile application now for sample registration in the field that works both on iPhones and on Android platform. The MySESAR workspace also allows users to group their samples. Possible group types are all samples that were funded through a certain award, a project group of samples, or a batch of samples that was analyzed together in the lab, samples that were handed out as a loan, and so on. That helps with the sample management, especially when the number of samples increases that are to be managed. This is the page that shows the transfer of ownership. Can be done either for individual IGSNs or for the entire set of samples and IGSNs that a user owns. Geosamples also provides the opportunity to users to upload additional materials for a sample, such as images and documents, and also include links to related data sources or publications. It also has capabilities to print labels for the samples in the lab or in the field. So I encourage everybody to participate. If you are an IGSN user, you can get an account at geosamples.org, and you can start registering your samples. There are help pages and tutorials to do so, and then start using the IGSN in your lab and in your publications. If you are an institution and interested in becoming an IGSN allocating agent, please contact the IGSN EV. We have a procedure for application laid out, and the IGSN General Assembly votes on these applications. And if you are, in general, a member of the community that deals with earth science samples and you are interested in the topics that we've talked about, please join the EarthCube Special Interest Group on Physical Samples. And this interest group is currently also working on an EarthCube RCN focused on the integration of geosamples into digital infrastructure and cyber infrastructure. Okay, that was it. So I'm looking forward to questions, and thank you very much for listening.
So questions, please put them in the chat window and send them on, and Leslie will read them out for Kerstin to answer.
As far as I can.
Yeah, while that's happening, Kerstin, I have a quick question. You showed the mobile app. Is there a mechanism by which you can register when you're not connected to an internet? Is there a way to do kind of an offline type process for these?
Not yet. The plan is to extend the capabilities of this mobile app are quite limited at the moment, and we really need to improve the interface, but we also want to add the capability to store information for as long as you're not connected. And that needs to include basically the capability to store your namespace on your mobile device so that you can generate numbers already, so you can print out labels while you're in the field and so on. So we hope that over the next year we can actually improve this mobile app quite substantially to make it more useful in the field.
Okay, thanks. We have another question here. So as an individual user, where should I go to look for a particular allocating agent?
Right now, actually the only active allocating agent is geosamples.org. The GFZ, the Geoforschungszentrum in Potsdam, and CSIRO in Australia are very close to releasing their allocating agent, but their infrastructure is still under the development. It will be in the future, you will be able to see that on the IGSN.org website, which allocating agent could take your samples and who to contact. But currently it's you can only go through geosamples.org.
The next question is, I noticed that age of sample is in the metadata. Can metadata be updated after the sample is collected?
Absolutely. That is part of the capabilities in the user account that you can edit metadata. And that's why it is a protected workspace, so there is control over the metadata by the person who registered the sample.
Okay, the next question. Sample registry is great for samples as we go forward. How can we use this system for thousands of samples that already have individual unique sample identifiers? What about linking to existing museum sample databases? Do existing identification data have to be manually entered into the IGSN system?
No, absolutely not. I mean, the entry of metadata for samples can happen through these batch templates that we provided, and we have quite a number of repositories that already registered their entire collections by sending basically database dumps and entering them into these templates that we can then upload. If it's even larger numbers of samples, we will do it through procedures here locally that will, but that can always be arranged. The metadata profile of samples has the capability to hold one or more other identifiers. So existing unique identifiers can always be used. We have not yet completed the integration into the IGSN metadata profile of other related unique identifiers. This is something we're working on, for example, in order to include the API numbers for wells, for oil wells. There has been a request for that, so we want to model that capability after the metadata profile of DOIs, where you can add related identifiers and related identifier types. So for example, if you have an API, it would be related identifier type API, and then we would store the number for that. Or for example, a life science identifier. This way, the IGSN is linked to other types of unique identifier schemes.
The next question is sort of related, and if I interpret this wrong, then please just write again. This one is, if samples are identified by a UUID or other GUID, can this be registered, or are IGSN values strictly controlled to format?
No, as I mentioned, we're loosening up the restrictions on the format. We have designed the IGSN, though, to be an identifier that can be used in conjunction for a physical object. So it should fit on labels. It should be easy to transfer onto labels and so on. So some identifier types that are very long, such as UUIDs can be, don't really, I think, serve the user in the lab very well. We can, in the new governance structure of the IGSN EB, such a proposal could be made by an allocating agent to use existing identifier schemes as IGSNs and register them as IGSNs, but they will need to have the namespaces that are administered by the IGSN registry.
So there are no other questions right now, but I just wanted to repeat that these questions and answers will be posted soon after this webinar. And also, if you have any other questions that you think of a little bit later, I will post in the chat an email address that you can send it to, or you can send it to Kerstin.
Absolutely. Would be happy to answer anything else.
Well, thanks again. And Leslie, why don't we go ahead and hand the control over to Sky for the next talk.
Okay. And I will unmute Sky very shortly.
Okay, Sky, when you get that, go ahead and take it away.
Okay. And did you also unmute Ricardo McClees?
Yep.
Okay, thank you very much. And can you hear me okay? Okay, you must be able to. I'm Sky Bristol with the U.S. Geological Survey, and we also have three other folks who will be providing parts of the talk today. Casey McKinney with our core center here and the paleontology collections, who's really the expert in this area from our team. The rest of us are mostly data folks on this, and I'll give you a little context here in a minute. Abby Benson as well here in the office in Denver, and Ricardo McClees in our office in Reston, Virginia. And so we'll all be giving a piece of this here. We're going to walk you through really what USGS is doing to get our overall paleontology records straight. That's what we titled this. So we'll be providing you an overview of what we're up to and why. All of this fits for the USGS within an area called Core Science Systems now. We reorganized, as government agencies are wont to do, not too long ago, into a number of different things, and we have an area that's really represented by this figure of the critical zone that I've got on the first slide here. So our piece of this really deals, the group that's working this project that we're going to describe today is really in the biological analytics realm and also in the collections realm of what we've described here in this figure. So just to give you a little context of sort of how this fits within the USGS. As a little bit more context, I'll point you to a recent science strategy that this part of USGS released, the Core Science Systems Group, where we described the idea of a modular science framework that you see here in the middle of this, schematic that is really based around the idea that we need to put together everything that we know across space and time in this construct of a vertical ecosystem that we borrowed from Bailey's idea of a vertical ecosystem. But so the piece that we'll focus on today is really this geological setting part, and but it's really in the context of a larger framework that we're bringing together to really support the entire research process over time. So I don't want to go into this in too much depth, but just to give you a little bit of a pointer for how this fits into the strategy of what USGS is doing. You can check this document out online, read the rest of what we put into that strategy. So for today, we're going to talk about our overall goal here, what we're trying to get to in terms of the best digital representation of really the full USGS Paleo record. And it starts with a lot of things that are in analog records to a great extent. I think we're kind of in the same boat as an awful lot of organizations who have these kinds of data, who have many samples and the records that are associated with those. We have file cabinets full of ENR reports and locality cards and other aspects of the analog records. Casey's going to talk about this in a little bit more depth here in just a bit and show you some other parts and pieces of that. We're working right now and have been working for some time to get those analog records into local digital databases of one kind or another. We have spreadsheets, we have FileMaker Pro databases, we have a few other kinds of databases out there where this information is being brought together locally at a given center, a given laboratory, areas where we have these paleontological records. And then we have, obviously the publication record, behind this as well, the geologic maps that the USGS has produced, professional papers that are posted out. And so the information source is really pretty rich, but all of the dots haven't been necessarily connected, and that's what a lot of these databasing efforts are going into right now. We're specifically then moving on to, okay, how do we bring this all together into an integrated database? All of these different collections from different labs, different centers that we have, how do we bring that all together into one integrated database where we can mobilize those data, better manage them into the future? And that's where a system that we have called ScienceBase comes into play. And we'll talk a little bit more about that in a couple minutes as well in terms of items and collections in that system that give us some capabilities to put things on a map, to explore those data in different ways. And then we're also specifically in this project working on how do we project these records out for other types of discovery, other types of use, whether it be the Paleobiology Database effort or Geosamples, as Kerstin just talked about, other places where we can push out either all of those records or certain aspects of those records where it makes sense, so that they're really out in the community and can be accessed through other platforms, whether it be public search engines where these things are accessible because of some things we've done to register them that way, or other ways of getting the records out. So I'm going to hand the mic over to Casey, who's going to talk about the Denver repository here and kind of tie in some of the pieces for you.
Thank you, Sky. This is a picture overview of the Denver repository here in Building 810. We've accumulated all the fossil cases that were left by the curators at the close of the Paleontology and Stratigraphy branch. And I've organized them from the oldest on the right, the early Cambrian, lower Cambrian, moving across stratigraphically approximately to the more recent in the Cenozoic way onto the left. There are about 1,000 cases here in our repository right now, plus a lot of ancillary cases of different racks and file cabinets and things like this. But this data is unique. This represents the collection, the stratigraphic collections were made in support of geologic mapping and natural resource assessments for the survey since its very inception back in 1879. We have different kinds of records, not only the fossils, but here stratigraphic columns are measured, sections are saved here, various of the scientists here, and field notebooks, invaluable resource that we're now beginning to harvest to supplement the databases. We have a lot of field maps, hundreds and hundreds of original field maps that, this is one of Mr. Cobben's field maps. They took to the field and recorded data on it. You can see the text space on the right side. He had a very small font, so you may have to read it carefully with a magnifying glass, but it points out point data on the maps is the highest resolution we can possibly have before GPS days. We take this data and put it in a high-res database, supplements our standard data that we convert from township and range. We're also going through a rigorous task of going case to case, drawer to drawer, writing down with a row of data for every identified sample that we can find. And this brings into bear also the possibility of making what was a locality catalog based with the best index fossil to relate in a one-to-many sense of the many that may come up within a drawer or a cabinet to an individual locality. So this way we can get our faunal list for biologic or taxonomic research in the future. Here's a typical drawer, and you can see this is heteromorphs primarily. There's a baculate on the right side, but primarily heteromorphs. And you can see the labels tucked underneath the fossils. You'll notice this is hard. Some of these go back in the 1800s. They're a little bit hard to read, and some of them are brittle, and we'll conserve those. And some of them do not have labels, so there's always opportunity to enhance an individual drawer or case with researchers' participation in the future to put additional labels in. We can't ask Mr. Cobben to work forever. He's already 97 or 98. Hasn't enough time. We've georeferenced about 27,000 of these unique localities in our Denver data set and Washington data set. So I've combined the two here. I didn't bother to separate them with colors, but this gives you an idea of how densely populated the western interior primarily is for the seaway during the Upper Cretaceous. That's what I really wanted to focus on for this. Data are dense. We have a lot of different forms of data, and Cobben started with an index fossil regime to record localities for about 80 or so individual species. And each species map has locality dots on it, and faintly you may be able to make out the line work that define what his interpreted shoreline would have been for that particular point of the stage, the Upper Cretaceous, of which we are now involved in a very interesting dynamic project here to map all those shorelines and putting up the 5,000 unique localities found on that series. And our partner, Abby, may have something to say about this.
Thanks, Casey. So hopefully this will, so what I'm going to do here is, what we have here is a visualization that I created. What I did was I took those fossil index maps that Bill Cobben had hand-drawn, pulled it into ArcGIS 10.1, and georectified them, and then hand-digitized those lines, the shorelines, and then created this visualization using a time series. And so you can see the movement of the seaway as it goes back and forth through time.
Yes, that's not coming across the WebEx for you. I did post the YouTube address down on the bottom there that you can pull in, and these slides will be posted out, of course, too. So this is very much a rough prototype at this point, but we'll be getting that finalized and moved along here in the not-too-distant future.
This will be queryable by stages, substages, or index fossils, so someone can pull the data set for any one of these maps that Abby's drawn and query it in new ways that we can't even imagine in a biologic sense or paleontologic faunal sense.
Really, all of this is geared toward, again, this is one kind of prototype example application that we're trying to get to. The point that we're trying to make here is that, this is all heading toward mobilizing these data, getting them out into the community where a lot of different kinds of things can be done. And we'll do a few of those through a new website that USGS is cranking up on this whole thing, but we'll be hopefully getting those data out in other forms to be used there. So I'm going to change over and pass the mic off to Ricardo in Reston. Are you on there still, Ricardo?
I am. Can you hear me?
Yep.
Okay, good. I guess that means everybody else can. Well, hello everybody. My name is Ricardo McClees, and actually I got started or involved with this project because last year I was working with, some of you may know, Mark Ewan, paleontologist with the Paleobiology website, which is now, I guess, changed its name. I've been out of the loop for a while, but when I went back to the website, I noticed it's FossilWorks. So with the FossilWorks website, for about a year, I inputted occurrence data for the order species known as Miliolita. And as a result of that, here I am today working on the USGS Paleontology Database. And for me, one of the main goals was to come up with a structured metadata schema that could be applied to USGS Paleo data, but then also be harvested into our database, which is ScienceBase. In addition, we also wanted the output to be digested by other databases like FossilWorks or even our own in-house database or other database, Bison, Biodiversity Information Serving Our Nation. So one of the first things I came up with, or what I did, was a spreadsheet. As you can see up here in the upper left-hand corner where it says locality information, mapped all the fields from one of our USGS scientists, which her name is Laurel Bybel. She's a nanofossil scientist. And I kind of used the framework of what FossilWorks had. Sorry, I keep thinking paleobiology. FossilWorks had. And so I mapped our fields to paleodb.org, kind of figured out what's missing because, of course, on our end, there's going to be a lot of fields that we need that FossilWorks will not need. So we had to come up and try to figure out how that came into play. And once I was able to pretty much sort everything out, I was able to come up with a conceptualized model, as you can see here in the lower right-hand corner. Now, that being said, this model on the lower right is not finalized. I imagine as more data comes in from other scientists, because right now I'm just working with nano fossil scientist data. As we get other data, more fields will come in and things will have to be tweaked with these facets. So as of right now, we broke up our sample into 6 different facets. We have our collection info, our stratigraphy info, our geology info, our locality info, our paleo sample info, and our taxonomy info. Now, some of the things we're trying to look at into the future is, maybe how we can tie in just regular hand samples. And what I mean by that is, say, a scientist in California has a hand sample. She had the chemical analysis, or she did the chemical analysis of it. Maybe she cut a piece off, sent it to a scientist in Reston, and they looked for fossils within it. How can we make sure all this information stays together, and how can we display this in our database? And that's one of the things that we're looking towards. Next slide, please. Now, this right here is essentially the original spreadsheet that was sent to me from Laurel. I must say there must have been over 60 fields that need to be mapped to what we had in ScienceBase and what was in FossilWorks. And here's just a little bit of close-up of the detailed information of the different various species. And this is what it looks like right now currently in ScienceBase. The new conceptual model that we have right now is not currently into ScienceBase, but that's one of the things that we'll be working on in the next few months. using this data set applied to my conceptual model. And this is one way of how it's displayed within Sciencebase using Google Earth.
Cool, thank you, Ricardo. And so just to wrap up, again, going back to our kind of overview slide, we have this work going on across a lot of different areas in the USGS, and really our records are scattered across different labs, different centers, various collections like the very rich collection that Casey showed here in Denver. We have many different forms of both analog records, paper records, and increasingly digital databases. But we're very much in a data preservation and even in some cases data rescue mode, trying to bring all of that into focus so that we have, as Kerstin alluded to earlier in her talk, some digital representation, the best digital representation that we can. Strategies like the IGSN, we're working toward that as well, and the implementation of IGSNs across all of these different resources that'll help with the problem that Ricardo alluded to there in terms of connecting the dots between samples that are maybe used for different purposes over time. So there's a lot of that that's tying in. And again, we are working to get that information together into our integrated data system and then project it out to various other platforms where it makes sense. But one way or the other, we're working to get our records straight so that we can get these data out for much broader use and mobilization. So with that, we'll take any questions.
If you have questions, please just put them into the chat window, and Leslie will collect them and ask
them. Okay, so I have some questions here and also a comment from one of the participants. And let me start with some of the questions since I see we have at least 10 minutes left. So the first question is, how much effort is going into preservation and rescue of legacy data versus putting systems into place for collection of new data?
Well, I don't have a number in terms of total dollars and cents, but it's fairly lopsided toward, you know, I mean, if you look at our total research budget and where money is going in terms of data management types of activities, there's not a tremendous amount that is going into the data preservation side and the data rescue side overall. The USGS and state geological surveys are part of a program called the National Geological and Geophysical Data Preservation Program that really the paleontology work that we're talking about here somewhat fits into, although there are aspects of this that are really USGS's, you know, responsibility. That program itself was really lobbied heavily for by the Association of American State Geologists, others really pushing for that. It was authorized at a fairly high amount a number of years ago, but it's only ever been funded at a fraction of what the legislation was authorized to do. And you know, the recognition was that, hey, we have these coffers of amazing information that's locked up because we never put it in some kind of digital form. We didn't really preserve it as well as maybe it could have in using state-of-the-art methods. And so, you know, we need to put some money behind this because these data are incredibly valuable to economic development, to understanding the effects of climate change and developing appropriate strategies to all kinds of different societal challenges that we have. But we never really put the amount of money into it that's been needed overall. So we're still pushing for that, and there are pockets of efforts that we've been able to move along both in the USGS and its state geological surveys to help make some headway on the vast amounts of information that we have, but you know, a lot more needs to be done there.
Okay, I'm going to go a little bit off script right now, and we have a comment from George Percival who made an observation early in the talk. So I'm going to unmute George right now. Okay, George?
Yes, can you hear me?
Yes.
Yes.
Oh, great. Yeah, it was back on the second or third slide, which showed the USGS Modular Science Framework, concept that I was not familiar with before, but I found the document that shows up in. It looks like that could be pretty valuable to some of the discussions in EarthCube about coming up with an approach that's the cyber infrastructure for EarthCube. And so I know it's a public document, but I would encourage, if you guys think, if you agree, this could be a basis for some discussions within the EarthCube assemblies and venues.
Thank you very much for that, George, and the lead author on that strategy. I appreciate it. And I've been very much paying attention to what's going on with the concept awards in EarthCube, and I'm a collaborator on one of those awards, and we're definitely working to bring some of these thoughts forward to the table. So thanks for the comment, and definitely look forward to future conversations on it.
Sounds great.
Okay, so the next question. I've been looking for information for USGS Menlo Park collections from quaternary coastal sites on the Pacific coast. Is there an organized source for this information?
That may be something that Casey may have a little bit more information on than I do. I'm not aware of any specific efforts right now that are working to bring that database into focus here. Ultimately, the goal of all of this, of what we've called our National Paleontological Database for USGS, is to integrate all of that into the science-based system, as we mentioned, the integrated database that we're bringing together there, and have a common portal to all of that through USGS, but also project all of that out, the information on those samples out through other registries for discovery and access. But do you know any more about collections out of Menlo, Casey?
We have some of the Menlo collections. We have the Triassic ammonites. We have the Cenozoic vertebrates. We do not have, we have the radiolarians here, but I don't know particularly about every collection because I was not involved in the Menlo branch ever. Some of the Cenozoic molluscs are actually at Berkeley right now. They were signed over from the Menlo office, about 200 cases of them directly to the Museum of Paleontology, which Mark Goodwin has kindly agreed that we can data share and have access to the data from their huge NSF grant. So some of it's will be coming forward out of the woodwork to me. It's interesting to see how many, we do have to take a survey of how many different curators were out there and track where did their data end up after the closure of the PNS branch in 1995.
So there's no other questions at this point, but we do have a little bit more time, and I will again type in an email address in the chat if anything comes up later, and we'll be sure to incorporate that into the write-up.
I think that you put a link to the PDF for the publication for this diagram that's currently on the screen?
Yes, that's correct.
Guy, I have a question while we're waiting to see if anyone else typed from begin here. All the scanning that's taking place on these notes, I know OCR is very inaccurate in these types of things, but is OCR taking place for those cases where you might be able to latch onto a keyword or two and place behind the scans?
Yeah, I was just talking to Casey about that the other day, so I'll let him address what they've been able to do and not been able to do through the scanning process.
I was looking at the Mesozoic collection data, our original Washington data from various curators, starting with White and Stanton and Stevenson and Reside, and it quite apparent to me that they were keeping a coffee table reference on everything that they read of significant discoveries, new taxonomy. And this took in a small library index card file, well, about, wasn't small, it was 2.5 feet by 2.5 feet. There were around 10,000 cards in it. a bulk of them were typed, and I ran them through a scanner at 300 DPI and ran it through OCR within Adobe Acrobat Pro, and I got superb results. It was smart enough not to mess with the images of handwritten, and it allowed me to look at, this was South American data, it allowed me to search through where it was Peru, where it was Argentina, where it was Colombia, and this was a particularly interesting experiment because Smithsonian has a tropical conservation rescue project right now in Colombia, and we have an incredible reference library for the foundations of that for the first 100 and some years of our fossil existence here. So yes, it is, some of it's available. It's getting better all the time, and it's much better than working off of our microfilms, of which we scanned 48 microfilms last year, none of which is high enough quality resolution for OCRing, but it does point out, well, we can go find those original locality cards and run them through the scanner as needed.
Great, thank you. Leslie, do we have any other questions?
There are no other questions at this time.
Okay, well, I think we'll conclude here. Thanks again to all the presenters today. This webinar, recording of this webinar will be available both at the EarthCube website and the C4P YouTube channel later. For future webinars, please check the C4P webinar schedule at earthcube.org. And thank you again to everyone.